In this video, we're going to talk about thermal expansion. Most materials expand when their temperatures increase. Liquids expand in a thermometer. A tight metal lid on a jar can be loosened by running it under hot water. And so these are a few examples of thermal expansion. We will consider two types of thermal expansion, linear and volume expansion. Suppose a rod composed of some substance that has a length L naught at an initial temperature of T naught is given to you. If the temperature is changed by delta T, the length also changes by delta L. If delta T is not too large, delta L will be directly proportional to delta T. The change in length would be defined as delta L is equal to alpha L naught times delta T, where alpha is the coefficient of linear expansion for that metal. You would have to find out the coefficient of linear expansion from a chart online or in the textbook. So here is a chart of examples of linear expansion coefficients for different materials. Notice that all of these numbers are multiplied by 10 to the minus 6, and they have the units of 1 over Celsius degrees. This should be Celsius degrees, not degrees Celsius. So let me go ahead and fix this. Temperature change is Celsius degrees, not degrees Celsius. A steel rod measures 10 meters at 0 degrees Celsius. Given that the coefficient of linear expansion of steel is 1.2 times 10 to the minus 5 per Celsius degree, what will the rod measure at 75 degrees Celsius? Go ahead and pause the video now. Okay, so let's take a look at the solution. Delta L is equal to alpha L delta T. So delta L is going to be equal to L minus L naught. So in order to find L, it would be equal to L naught plus delta L. Substituting in for delta L, which is going to be alpha L naught delta T, and factoring out an L naught, substituting in the numbers, we end up with a length of 100.09 meters. I did a lot of shortcuts here. So if you're unclear about how they got this formula, just let me know through Edmodo. Okay, a simple pendulum is made of a steel string supporting a brass sphere. The temperature in the room with the pendulum is increased from 15 degrees to 30 degrees. Which of the following is true about the period of oscillations? The period doubles. The period does not change. Does not unchanged. I'm not sure what that means. The period slightly increases. The period slightly decreases. The period increases by the square root of 2. I believe this is supposed to be that the period remains unchanged. Okay, so let's take a look at the answer. The answer is C. It will be slightly increased. The absolute temperature increases from 288 Kelvin to 303 Kelvin, so the length increases slightly. That means that the period will also increase slightly since it's equal to 2 pi times the square root of L over G. Suppose a volume of some substance, whether it be a gas, liquid, or solid, has a length of a volume of V naught and an initial temperature of T naught. If the temperature is changed by delta T, then the volume will also change by delta V. Again, if this change is not too much, there will be a direct proportional relationship between delta V and delta T. We define the change in volume as beta V naught delta T, where beta is the coefficient of volume expansion. So here are some examples of the coefficient of volume expansion. And again, we multiply all of these numbers by 10 to the minus 6 times 1 over Celsius degrees. A glass flask is filled to the brim with glycerin. both at the same initial temperature. When the temperature of the flask and glycerin is increased by a few degrees, which of the following occurs? They give you the coefficients of volume expansion for glycerin and for glass. Go ahead and pause the video now in order to choose the correct answer. Okay, so let's see if you chose the correct answer. The correct answer is C. The glycerin has a much greater coefficient of volume expansion than the glass. So consequently, the temperature rises, the glycerin will overflow. Let's talk about volume expansion of water. Water above 4 degrees Celsius expands when heated, but in the temperature range from 0 to 4 degrees, the volume decreases as the temperature increases. This means that at 4 degrees Celsius, water is more dense than at 0 degrees Celsius. Hence, water has its greatest density at 4 degrees Celsius. 4 degrees Celsius water will sink to the bottom of the lake, so ice will form in the 0 degrees Celsius water floating on top. This protects life in bodies of fresh water, since the water on the bottom will be at worst 4 degrees Celsius, which is not freezing. In the next video, we'll talk about heat and temperature change.